In yesterday's lesson, we talked about ionic compounds and how they form by electrons being transferred from a metal to a nonmetal. In this lesson, we're going to talk about covalent compounds. In covalent compounds, electrons are being shared between two or more nonmetals. So we are now in Roman numeral 3 of the notes packet, an introduction to covalent bonding. Covalent compounds are formed when atoms of hydrogen in the nonmetals from groups 4a to 7a share their electrons. They will often share electrons so that each of the atoms has a total of 8 valence electrons. But hydrogen only gets 2. Remember that all atoms want to become like the noble gases to be stable. Almost all noble gases have 8 valence electrons, except for helium, which of course only has 2 electrons. So hydrogen only needs 2 to be like helium. The individual units of covalent compounds are called molecules. If you recall from yesterday, we said the individual units of ionic compounds are called formula units. So molecules would be the analogous form of formula units, which is also analogous to atoms. Unlike ionic compounds, the atoms that form covalent compounds may be bonded in more than one way. For example, carbon and oxygen can form something like carbon monoxide, CO, or carbon dioxide, CO2. This is different than what we talked about yesterday for ionic. Remember how we kept going back and forth until the cation could give away all of its valence electrons and the anion could gain all that it wanted? So with covalent, you have the different combinations possible. The formation of covalent bonds may be demonstrated by electron dot structures, just like we did yesterday with ionic. A single covalent bond forms when one pair of valence electrons is shared. An example would be between two hydrogen atoms. So here's my two hydrogen atoms. One is in red, it has its one valence electron. The other in blue has its valence electron. So instead of the dot to empty spot that we use for ionic, for covalent, we're going to draw a line joining dot to dot. This is because they're being shared. There's not a direction because they're each sharing with one another. So if I draw that line to show that these electrons are being shared, we're showing that each hydrogen now has 2 valence electrons. Similarly, fluorine has 7 valence electrons. Fluorine has to get up to 8 because it wants to be like the nearest noble gas, neon. So this fluorine and this fluorine both have a very high ionization energy. Neither one wants to give away an electron. They have a high electronegativity because they want to gain electrons. So instead of one giving to the other, again, they share. And we show this by a line that goes from dot to dot. Now watch this. 1, 2, 3, 4, 5, 6, 7, 8 for the red fluorine, and the blue 1, 2, 3, 4, 5, 6, 7, 8. So now each fluorine has access to 8 valence electrons. 6 that it still has for itself, and then 2 are being shared. In a double covalent bond, there are 2 pairs of electrons being shared. 2 oxygen atoms will form a double covalent bond. You can see here that each oxygen starts with 6 valence electrons. Notice that I know they're going to share 2. I put the 2 green dots facing these 2 blue dots. That's because I'm just going to draw 2 lines connecting green to blue, green to blue. Again, I should always be able to count 8 or an octet around a single atom. 1, 2, 3, 4, 5, 6, 7, 8. I could do likewise with the blue one. What do you think a triple covalent bond is? Forms when 3 pairs of electrons are shared. And we have these nitrogens with 5 each. So they're going to share 3 times. So dot to dot, 3 different times. So we can see that we've got each nitrogen with 1, 2, 3, 4, 5, 6, 7, 8. Each of these examples was formed when two atoms of the same element. They are called diatomic elements. Di is two, and then atoms. So they're elements that always have two atoms. The elements whose atoms form this type of molecules are easily found on the periodic table. So there are those gases over here, not the noble gases, because remember they don't want to form any kind of compound really. And then also bromine and iodine, those other halogens. So hydrogen is one. Then we have 6 more. Notice that this makes the shape of a 7, starts on number 7. And if we count 1, 2, 3, 4, 5, 6, hydrogen is actually the 7th one. So again, there are 7 of them. They start on atomic number 7, and they make a 7. So they are H2, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. The key about these elements is in nature, you will never just find a H atom. You'll never just find an N atom. If they're not part of another compound, they're always going to be buddied up with one of the same thing. So you'll never find oxygen just as an atom in nature. It might be part of something like H2O for water or C6H12O6 for glucose, but never just O. It would be O2. The bond is formed where electrons are shared. The other electrons are called unshared pairs. So if we look back at nitrogen, these 2 electrons, that would be an unshared pair. Same thing with oxygen. This oxygen has 2 unshared pairs. These 2 and then these 2. Those are each a set of unshared pairs. So where we have the bond, that's the dot to dot. The other electrons that are not connected dot to dot, those are called the unshared pairs. So they're not always going to be diatomic elements when you do a covalent compound. We're going to start with some simple covalent compounds today that have more than one type of atom. So water is H2O. What that means is we have 2 hydrogens and an oxygen. You don't always have to do this list, but it probably will help you to start off. So I'm making a chart. I've got hydrogen, hydrogen, and oxygen. I'm going to look at how many valence electrons each has, and then how many bonds they need to be full, like a noble gas. So remember, hydrogen only has 1 valence electron, and it needs 1 more to be like helium. What about oxygen? Oxygen has 6 valence electrons, and it needs 2 more because it needs to be like the nearest noble gas, neon. So when you're doing this kind of a compound, you always want to make sure that you're realizing that the one that needs the most goes in the middle. You might even want to make a note of this somewhere on your paper. The one that needs the most is the one that will go in the middle. So in this case, oxygen needs 2, so I'm putting it in the middle of 2 hydrogens. And what I'll notice is that 1 plus 1 equals 2. So each hydrogen needs 1 and oxygen needs 2. So what I can do is I can say, okay, dot to dot here. Oxygen has shared 1, hydrogen has shared 1. Dot to dot here. That hydrogen has also now shared 1, and oxygen now has shared a total of 2. And again, 1 plus 1 equals 2. I can count my octet around oxygen. 1, 2, 3, 4, 5, 6, 7, 8. And of course, hydrogen didn't need a full octet. It only needs the 2 electrons. Ammonia is NH3, not to be confused with that polyatomic ion ammonium, which is NH4 with a positive 1 charge. Can you figure out how many valence electrons the N and the 3 H's have, how many they need? So N has 5, it needs 3 more, and each H has 1 and needs 1 more. So what's going to go in the middle? The one that needs the most, nitrogen. Nitrogen's in the middle, and we've got hydrogens on 3 different sides. Nitrogen has 5. Notice I pointed 1 toward each hydrogen because I know it'll share with each hydrogen 1 time. And then each hydrogen has 1 valence electron, which I've of course pointed toward the nitrogen. So here this hydrogen shares 1, this hydrogen shares 1, this hydrogen shares 1. So nitrogen has 8 altogether. 1, 2, 3, 4, 5, 6, 7, 8. I would encourage you to pause and try the next one before you check. Okay, so methane has a carbon and 4 hydrogens. Carbon has 4, needs 4. Each hydrogen has 1, needs 1. Of course, I'm going to put carbon in the center. And carbon has 4, and each hydrogen has 1. And 1 plus 1 plus 1 plus 1 equals 4. How about carbon dioxide? CO2. Dioxide is 2 oxygens, so try CO2. Carbon has 4, needs 4. Each oxygen has 6, needs 2. It's a little different than what we've seen, but still very similar because 2 plus 2 is equal to 4. So if you put the carbon in the middle, because it's the one that needs the most, this time each oxygen is going to share 2 times, and that's going to give carbon a total of 4 to share. I can count 1, 2, 3, 4, 5, 6, 7, 8. On my carbon, I can count 1, 2, 3, 4, 5, 6, 7, 8. Now that you've done both ionic and covalent, let's mix them up and figure out how they look different. First of all, how will you know if it's ionic or covalent? Well, don't forget, ionic is going to have both a metal with a nonmetal. And when you do an ionic, don't forget also that we're doing dot to empty spot. So we're using an arrow because we're showing transferring. When you do covalent, don't forget it's sharing. It's only nonmetals, and you're going to go from dot to dot. So you'll have a line.